Welcome back. Objective 4.7 Automation and Orchestration in Security. The discipline of letting computers do the repetitive parts so humans can do the parts that actually require thought. We are going to walk through SOAR, the use cases, the benefits, and the risks, because the exam asks about all four and gets specific about the trade-offs. Picture this: mid-size SOC, 15 analysts, a new alert comes in. Phishing email reported by a user. The runbook is well documented, 8 steps. Pull the email from the user's inbox, extract the headers, look up the sender domain in VIRUSTOTAL, check the link reputation, query the proxy logs for any clicks, search the SIEM for any user who actually opened the link, isolate any host that did, open a ticket, 8 hours on a good day, 2 analysts touching it across shifts, 12 emails like this every day. The team is drowning. The team builds a SOAR runbook for this exact workflow. 8 steps become 8 minutes. The SOC goes from drowning to processing 12 a day before lunch and pivoting to threat hunting in the afternoon. Anyone who has ever owned in SOC Tier 1 queue knows this story. Automation is not a tool problem. Automation is a survival strategy. Today we walk through how it works and where it breaks. Start with definitions. Automation is using technology to execute tasks without human intervention. A single task. Block this IP. Open this ticket. Run this query. Orchestration is coordinating multiple automated tasks and tools to complete a workflow. The 8-step phishing response above is orchestration. Multiple automated tasks chained together with conditional logic, decision points, and integrations. Is security orchestration, automation, and response, the platform category that combines all three. Playbook is the documented manual workflow. Runbook is the automated version that the SOAR platform actually executes. The exam will distinguish Playbook from Runbook. Playbook is the procedure on paper. Runbook is the code that runs. The same workflow exists in both forms in mature SOCs. The Playbook for new hires to read, the Runbook for the system to execute. 2 related terms. IAC, infrastructure as code. Define infrastructure in code with tools like Terraform, Ansible, CloudFormation. The infrastructure is reproducible, version-controlled, auditable, and reviewable in pull requests, like any other code. CI/CD, continuous integration and continuous delivery. Pipeline for automated software delivery, where code is tested and deployed automatically as developers commit. Both intersect with security automation, and the exam will reference both. The DevSecOps movement sits at this intersection. Security checks built into the CI/CD pipeline so insecure code never reaches production. SOAR capabilities. 5 of them. Orchestration. Integrates multiple security tools. SIEM, ticketing, threat intel, EDR, firewall, identity, email gateway into a unified workflow via APIs. The SOAR is the conductor, the security tools are the orchestra. Automation. Executes actions without human intervention. Block IP. Isolate host, open ticket, query a database. Response. Executes automated containment and remediation actions. Case management. Tracks incidents from detection through closure with timestamps, evidence, and analyst notes. The audit trail for every action taken. Threat intelligence. Enriches alerts with threat feeds, VIRUSTOTAL lookups, IP reputation checks, domain age lookups, indicators of compromise correlation against MITRE ATT and CK and STIX feeds. Example SOAR workflow expanded. SIEM fires alert. Suspicious outbound connection detected. SOAR queries threat intel automatically. Is this IP malicious? When was the domain registered? Has it been seen in any ISAC feed? If confirmed malicious, SOAR blocks the IP on the firewall via Firewall API, isolates the endpoint via EDR API, opens a ServiceNow ticket with all the evidence attached, and notifies the analyst via Slack. Total elapsed time, under 30 seconds. The analyst reviews the SOAR build ticket, confirms or rejects the action, and closes the case. What used to take 30 minutes of manual work happens in under a minute, and the analyst spends their time on judgment instead of clicking through tools. SOAR platforms, the names you will see: Splunk SOAR, formerly Phantom; Microsoft Sentinel, which has built-in SOAR capabilities through logic apps and automation rules. Palo Alto XSOAR, formerly Demisto. IBM Security SOAR, formerly Resilient. The exam may reference any of them. The vendor matters less than the concept. Every SOAR does the same essential work, just with different user interfaces and integration libraries. Use cases for security automation. 7 big ones. I am going to rank them by how much value they actually deliver in a typical SOC, from highest to lowest. Number 1. User provisioning and deprovisioning. Automated onboarding. HR submits new hire ticket. Automation creates the account, sets up email, enrolls the device, grants app access based on role. Deprovisioning. Termination ticket triggers immediate account disable, access revocation, MFA removal, mailbox forward to manager, and device wipe. This single automation closes the orphan account problem from 4.6. The reason orphan accounts exist is that the manual termination process is slow and error-prone. The HR team submits the ticket, IT processes it whenever they get to it, the VPN team has their own queue, the cloud team has theirs. By the time everything is closed out, the former employee has been gone for 2 weeks. Automation collapses that into seconds. Number 2. Guardrails. Automated policy enforcement on cloud configurations. If a developer flips an S3 bucket to public, the guardrail detects it within minutes and either blocks the change or auto-remediates by flipping it back. Azure policy auto-remediates non-compliant resources. AWS config and service control policies do the same. Guardrails prevent the mistake from persisting long enough to be exploited. They do not just alert, they fix. The exam may use the phrase guardrails specifically. It means automated remediation, not just monitoring. The opposite is gatekeeping, where every change waits for human approval, which works for low-volume changes and breaks at cloud scale. Number 3. Security group management. Automatically add and remove users from Active Directory groups based on HR role changes. Promotion from analyst to senior analyst triggers the addition to the senior analyst group. Department transfer triggers removal from the old department's groups and addition to the new department's groups. Real time, no ticket, no manual error, and the access actually reflects current job function instead of accumulated history. Number 4. Ticket creation and escalation. SIEM alert automatically creates an incident ticket with relevant context attached, the affected user, host, source IP related events, threat intel enrichment. Escalation workflows. If a ticket is not acknowledged within SLA, the system escalates to senior analyst or management automatically, reduces MTTR, which is mean time to respond, and ensures nothing falls through the cracks at shift change. The handoff between night shift and day shift is one of the most fragile moments in any SOC, and automated escalation is what catches the alert that nobody picked up. Number 5. Enabling and disabling services. If a user account is flagged for anomalous behavior, automation disables the account pending investigation. Automated firewall rules block or unblock based on threat intelligence updates. Threat feed-driven blocking. When CISO, KEV, or a private intel feed adds an IP, the firewall blocks it within minutes. The trade-off here is over-automation risk. Automatically disabling a CEO account because of a behavioral anomaly is a career-limiting move, so high-impact actions usually require human-in-the-loop approval. The general rule: automate where the cost of a wrong action is low, require approval where the cost is high. Number 6. CI/CD pipeline security. Shift-left security integrates security scanning into the build pipeline. SAST scans the code. SCA, software composition analysis, scans the dependencies for known vulnerable libraries. Secret scanning catches credentials checked into the repo. Code fails the build if vulnerabilities above threshold are found. DevSecOps means security is integrated throughout development, not bolted on at the end. Automated container image scanning before deployment, scanning the running container against CIS benchmarks, scanning the IAC templates for misconfigurations. The exam will use the phrase shift left and you should immediately think CI/CD pipeline security. The opposite, shift right, refers to runtime security testing in production, also valuable, but the shift left phrase always references finding issues earlier in the pipeline. Number 7. Infrastructure as code. Define all infrastructure in code, version controlled, reproducible. Terraform, Ansible, CloudFormation, Pulumi, Bicep for Azure. Benefits. Every environment is identical. You can review changes before deploying. You have an audit trail and version control. You can roll back. Security tools that scan IAC before deployment. Checkoff, TFFsec, KICS, SNCC IAC. Catch the misconfigured S3 bucket in the pull request, not in production. The pattern across all of these: find issues earlier, find issues automatically, fix issues before they hit prod. Manual review of infrastructure does not scale. Automated review does. Benefits of automation. 7 of them. The exam may pull any of them as a correct answer. Efficiency gains. Tasks that took hours done in seconds. Analysts focus on higher value work like threat hunting and tuning. Consistent baselines. Same configuration applied every time. Human variation eliminated. No more "it worked when I did it" issues. Standard infrastructure configs. IAC ensures every environment is identical and secure. Dev matches, staging matches, prod. Secure scaling. Auto-scaling cloud resources automatically inherit security controls because the security controls are part of the IAC template. Employee retention. Removing toil improves analyst job satisfaction, reduces burnout, lowers turnover, saves the cost of hiring and training replacements. Faster reaction time, sub-second automated responses versus minutes or hours for manual. The difference between catching ransomware before it spreads and catching it after. Workforce multiplier. Small team can manage larger environment, do more with the same staff. Automation is how a 15-person SOC protects a 100,000 employee enterprise. Pay attention to that fifth benefit: employee retention. The Security Plus exam explicitly calls this out. Burnout in SOC analyst roles is real. The turnover rate is high. Analyst tenure in many SOCs averages well under 2 years. And the single biggest contributor is repetitive toil. Automate the toil and the analysts stay. The exam may use the phrase employee retention as an option. And yes, it is correct. Anyone who has watched a senior analyst quit because the queue never gets shorter knows this is not a soft benefit. It is a real cost the CFO understands. Considerations and risks. 7 of them equally testable. Complexity. Automation systems have many moving parts, harder to troubleshoot when they fail. A SOAR runbook with 12 integrations breaks in 12 different ways. Mitigation. Document thoroughly. Test in staging first. Build observability into the runbooks themselves. Cost. SOAR platforms and implementation are expensive, 6 figures for the platform, plus ongoing engineering time, plus integration costs to every connected tool. Mitigation. Build the business case with ROI. Start with the highest value use cases. Single point of failure. If the automation system fails, manual processes must be ready to take over. Mitigation. Build redundancy. Maintain manual runbooks alongside automated runbooks. Run incident response drills assuming SOAR is unavailable. Technical debt. Complex automations become difficult to maintain over time as tools change and integrations break. Vendor APIs change without warning, and the runbook that worked last quarter silently fails this quarter. Mitigation. Regular reviews. Keep automation simple and modular. Monitor the runbooks themselves. Ongoing supportability requires dedicated staff with automation expertise, often a SOAR engineer or two. Mitigation. Document all runbooks. Cross-train the SOC team so the SOAR engineer is not the single human point of failure. Over-automation risk. Automated response can take incorrect action, like blocking legitimate traffic, disabling a critical account, or quarantining a CEO's email server. Mitigation. Human in the loop for high-impact actions, automated for low-impact, the line drawn carefully. Integration challenges. Tools must have APIs. Legacy tools may not support automation. Mitigation. Evaluate API support before purchasing tools, or replace the legacy tool or build a bridge with a custom script. Single point of failure deserves emphasis. If your SOAR is the single choke point for incident response, what happens when SOAR is down? The SOC reverts to manual, but only if the manual procedures are documented and the team is trained on them. SOAR makes you fast. SOAR also makes you fragile if you are not careful. The cure is keeping the manual playbooks current alongside the automated runbooks and running tabletop exercises that assume SOAR is unavailable. If you have ever lived through a SOAR outage during an active incident, you know the second worst feeling in security is realizing your team has not actually run the playbook by hand in 18 months. Automation in the security lifecycle. 5 phases, examples in each. Prevention. Auto-apply patches, enforce config baselines, IAC deployments. Automated user lifecycle. Detection. SIEM correlation rules. Automated threat hunting queries. Scheduled vulnerability scans. Response. SOAR playbooks block IPs, isolate hosts, reset credentials, quarantine emails. Recovery. Automated failover, backup restoration scripts, infrastructure rebuild from IAC. Compliance. Auto-generate compliance reports, continuous compliance scanning, evidence collection for auditors. Automation lives at every phase. The mature security program automates the parts that should not require human judgment and pushes humans to the parts that do. Quick recap as a 5-step automation program. 1. Start with documented manual playbooks. You cannot automate what you have not documented, you will just be automating chaos. 2. Pick the highest value use case for your environment, usually phishing response, alert enrichment, or account provisioning, because those are the ones with the most repetitive volume. 3. Build the runbook in your SOAR platform with human-in-the-loop checkpoints for high-impact actions, automated for low-risk steps. 4. Measure the gain. Time saved per incident, MTTR reduction, analyst hours freed. Use the data to justify the next runbook to leadership. 5. Maintain. Tools change, APIs change, the runbook breaks, the team has to keep it current. Automation is not a one-time project. Automation is a product the security team owns and maintains alongside everything else they own. One more thought before we close. Automation is a force multiplier, not a replacement. The exam may set up a scenario suggesting automation will solve everything. That is a trap. Automation handles the repetitive, well-defined work brilliantly. Automation cannot replace analyst judgment on novel threats, complex investigations, or executive decisions during incident response. The right framing: automate the toil, free up the humans, let humans do the work humans are good at. That is the entire pitch. That is objective 4.7. The phishing response runbook in our cold open is the typical SOC transformation. The team that drowned is the team that ships now. SOAR is orchestration plus automation plus response. Runbook executes the playbook. Employee retention is a real benefit. Single point of failure is the biggest risk. Next up, objective 4.8, incident response. We are going to talk about the breach call that came in at 11 p.m. and the IR lifecycle that has to follow. See you there.